So if we are to compute expressions involving hyperbolic functions naman, it helps to know yung mga identities relating them. So hindi lang sila sa notation nagkakaparehas, pati yung mga identities na nag-i-involve sa kanila ay halos magkakamukha din. So let's say you have your reciprocal at saka quotient identities for trig functions, kaparehas sila ng hyperbolic. So konting lang, sech x is just the reciprocal of cosh x. Cosech x ay 1 over sinh x at ang coch x ay 1 over tanh x. So for the quotient identities, parang ang tangent x mo ay sin x over cosine x. Ganun din for hyperbolic functions. So tanh x ay sinh over cosh. Tapos yung coch naman ay cosh over sinh. Tapos since from the definition, medyo simple yung itsura ng hyperbolic sine at sa cosine natin, may extra identity tayo dito. So cosh x plus sinh x equal yan kay e to the x at ang difference naman ay e to the minus x. And then, meron tayong cosine squared x plus sine squared x equal to 1. May counterpart yun for hyperbolic pero medyo mag-iiba yung sign. So, ang cosh squared x minus sinh squared x ay equal to 1. And since nagbago yung sign nito, mag-iiba din yung iba nating Pythagorean identities relating tanh and sech, coch, and cosech. So, take note lang yung difference ito from the usual Pythagorean identities involving trigonometric functions. Meron din tayong double measure or double angle identities. Yun yung tawag natin minsan sa trigonometric identities. So, yung sin 2x natin, it is equal to 2 sin x cosine x. For hyperbolic functions, medyo ganun din. Since 2x is just 2 sinh x cos x. Again, yung usual na pagkakamali, kapag gusto mong kunin yung sinh 2x, hindi lang ilalabas yung 2 doon. And for cos 2x, so nakalagay in red, yung cosine 2x equal to cosine squared x minus sine squared x, hindi lang nilabas yung 2. So for cos, ganun din, mag-iiba lang yung sine. And then, yung dalawa pang equality, pwede rin silang in place of cos squared x plus sin squared x. Kahit ano sa mga yan, pwede nyong gamitin. And then, we also have yung sum and difference identities, si cos cosine sin, at saka sin cos cosine. Okay, so kunwari, cos x plus or minus y, cos plus or minus sinh. And for sinh x plus or minus y, you have sinh cos plus or minus cos sinh. So let's try to prove some of the identities, in particular yung 3 and 5. So cos x plus sinh x. So sabi ko nga nako-follow lang to immediately from the definition. So recall, pag may time. Simplifying terms, you get this, which is equal to e to the x. And let's say you consider cos squared x minus sin squared x. I hope na recognize natin that this is a difference of 2 squares. So factoring it out, we get this. And assuming na prove na natin yung isa pang identity na ang cos minus sin ay e to the minus x, pwede na natin gamitin yon. So this is equal to 1. Isa pa to na usual na problem sa trigonometric. You have your trig function, one trig function you are to compute for the other trig functions. Pwede rin natin gawin yun for hyperbolic functions. So dito given si tanh, how do you get the other hyperbolic functions? So yung pinakaunang nakukuha talaga ay using your reciprocal identities. So since si tanh x ay 12 over 13, so ang coch natin ay 1 over yon, which is 13 over 12. How about sech x? So dito papasok yung tinatawag nating Pythagorean identity. So naka-red siya, bakit? So square root ng 1 minus tan squared x. Kasi dun sa Pythagorean identity, naka-square din si sech. So dito we get the square root. And if we get the square root, usually we use plus or minus. Pero dito, plus lang yung kinuha natin. Bakit kaya? So malalaman ang sagot from the graph of sech x. Tignan nyo na lang. So, plugging in the value of tanh x and simplifying, we get 5/13. So, madali mo makuha yung cos x, reciprocal identity ulit. And then si sinh x, paano naman to? Paano kaya? Gamitin mo naman si quotient identity. May cross multiply ka lang doon. And then plugging in the values and simplifying, you get this. And yung last natin ay cosec, nagagamit ka lang ng reciprocal identity.